We've now had a couple of days of working with systems of equations using substitution. We are now going to use the third method, which is elimination. So, thinking about all the I can statements for this chapter, I can solve two systems of variables using elimination. Today we're going to learn that. I can demonstrate replacing one equation with the sum of another multiple that creates a system of equations from the original. I can explain why some linear systems have no solution and ones that have infinitely many solutions. So up to this point, we now know we have three methods for solving linear systems. We have graphing, substitution, and elimination. Today we're going to explore elimination. What elimination just means is that we're going to look at a system and try and add them together. What we're trying to do is picture one variable to eliminate. And as you look at this equation with 2x plus 5y equals 17 and 6x minus 5y equals negative 9, we want to try to eliminate one variable. So if we think of adding these two things together, which variable would cancel? And in this case, the coefficients of y, one is positive 5 and negative 5, are going to end up to be 0. So we are going to add these two equations together. As we add them together, what you're going to notice is that we now have 8x plus 0 equals 17 plus a negative 9 is 8. We're going to solve this system for x. So 8x equals 8, that means x has a solution of 1. Once we have the 1 answer, remember, we're still looking for our solution to be an ordered pair. So we've now found what x is. Does it matter which equation? No, we're going to go to the first one, 2x. So instead of 2x, we're going to use 1. So we now have 2 plus 5y. We're going to subtract 2. When we subtract 2, we are going to end up with 5y equals 15, and when we divide by 5, y is equal to 3. So our ordered pair solution is 1, 3. It says, when you think about elimination, the plan should be, can you eliminate either of the variables? If the coefficients of y, if they happen to be opposites, that's the one you want to eliminate in your first step. So again, we check that it was 1, 3, and we want to check it in this last equation. 6 times 1 minus 5 times 3, does that give us negative 9? And in this case, 6 minus 15 does give us a negative 9, so it checks. As you look at problem 2, as we solve this system, you might be wondering why the letters A and S and what they're using them for is that later we're going to be doing some speed problems and working with an airplane speed. So if we're looking at this one, a plus s equals 101, and 2.5a plus s equals 164. So, as we look at our equations, we notice that the s's both have a 1 in front of them, but they both have a positive 1. So, what we're going to do is we are going to multiply one of our equations. As we look at that, we want to think, and the thing say of subtracting the equations. I think a better way of thinking about it is if we're subtracting it, is everything in this equation is going to be multiplied by negative 1. And as we multiply that by negative 1, we are now going to have, as we are adding those together, a negative 2.5. This becomes a negative s, and this is a negative 164. So when we add those, we get negative 1.58. The s's cancel to give us 0, negative 63. We now want to divide both sides by negative 1.5, and as we divide by negative 1.5, our solution is going to be 42. Now, to me, the easiest equation is the first one. A plus s equals 101. So we simply want to substitute in what a is, so 42. Subtract 42, and our solution is 59. So as we are solving this system, our answer is going to be the ordered pair. Remember, it's always an ordered pair. And in this case, you could tell us A is equal to 42, 42, and S is equal to 59. Or again, you can put it as an ordered pair, 42, 59, usually in alphabetical order, in this case, A and S. It's your turn to show that you got it. So, what I will be looking for in your homework tonight in your notes, when you do the notes, is adding these two systems. The nice thing about this one is notice you have different lead coefficients, so you should be eliminating the y. Do not forget that you need an answer for both x and y. In this second one, my hint would be multiply one of your equations by -1. It doesn't matter which equation you multiply by -1, but you have to decide. And then multiply every single term by that -1. Then you should be able to add those together. We will look for these two in your notes tomorrow when you come in. Don't forget that in this case, again, you probably would have C and T for your solution. So again, just like with elimination and substitution, we want to think about our problems and when we could have one solution, infinitely many, no solutions. When you look at this system when we try to use elimination, you're going to notice that our lead coefficients really aren't the same. But what's similar in this case is our y's. So to eliminate a variable in this equation, we want to add them together. But first, in order to get different signs but the same lead coefficient, we can multiply this second equation, everything by 3. So what we want to do is think of multiplying everything by 3. So when you start your homework, you'll put down the two original systems. You'll multiply it by 3 and you'll rewrite it right next to it so that you can now see the new equation. I'll often have students ask me, Mrs. Thompson, do I have to write the original? Yes. Show the multiplication. Why? Because when you finish solving, you always want to go back to your two original equations to get your solution. So make sure you have both of those done. In this case now, look at how nice that is. The y's cancel. So we're adding our x's and we get 19x plus 0. Oh, this is working out nice to give us a nice integer, and x in this case is 1. Does it now matter which equation? No, they went to the second equation. So 7 times 1 minus 5y. So when we subtract 7 from both sides and then divide by -5, we should have 10 is equal to -5y. So y should be equal to a -2. Again, after you check and you get your solution, make sure you go back to that other equation. Now, we use the second one, so we're going to go back to the first one for our check. To do the check, we're going to put -2 times, and I should see this on your paper, 1 plus 15 times a -2. Does that equal -32? -2, -30, and it checks. In problem 4 of solving systems, you're looking at multiplying both equations. Well, as we look at our equations, we are going to be looking at these two equations, and as we look at them, what you notice is that neither one of them have the same lead coefficient, so we can't really decide should we eliminate y's or x's. In this case, we're going to look at the y's. And what happens is, what number do both 2 and 3 go into? And what we also have to keep in mind is that the signs need to be opposite. So in this case, I know they say multiply the first one by 3, which is what we are going to do as we multiply by 3. We're going to multiply the second equation not by 2, but by a -2. And the reason we want to multiply by -2 is we want the lead coefficients to be opposite. So we want to have -8x, -6y, and in this case, a +4. So that what happens is that instead of subtracting the equations, we're going to add them together. So we are going to now end up with 1x, or x, plus 0 equals 7. Once we get that solution, we're going to substitute in 7 for x in our first equation. We begin to solve, and 2y equals -20, and we subtract 21 from both sides. We now want to divide by 2, and our solution is -10. So remember, our ordered pair is 7, -10. How would we check it? We would want to go to our second equation at this point, and once we go to that second equation, we're going to put in 4 times 7 plus 3 times -10 is equal to -2. And if we think about that, 28 plus -30 does equal -2, and it checks. As we do the problems in class, what you want to be thinking of is kind of thinking about this flow chart here, deciding the steps in order to solve with elimination. First thing you want to think, can I eliminate one variable by adding or subtracting the two equations? If it's yes, do it, and you should come up with your solution right away, x, y. If it's no, can I multiply one of the equations by a number? and then add or subtract? If it's yes, do that, multiply. If it's no, can I multiply both equations by different numbers and then add and subtract? And that's what I want to show you in this next one. Again, we're only going to be multiplying one of the equations, but as we get into our homework, we will be doing some where you have to multiply both equations. So kind of keep this flow chart in mind. Again, thinking about false statements when we have no solution, and the identity when we're going to have infinitely many. And as we look at this system, we look at the system and our x's and our y's don't have the same coefficient, but let's try and eliminate the x's. If we do that, we want to multiply everything by -2. And what you notice is when we start multiplying by -2, we get -2x minus 6y, and 18 equals -18. If we add our equations together, 0 equals 0. And because 0 is equal to 0, we got the identity, and there are infinitely many solutions to this problem. We're going to be practicing quite a few of these in homework, but what your job is as you look at these two, look back at your notes. If you need, take a look at the other ones on Pearson also, and we want to try and eliminate. Now my key in this one is I would try and eliminate the y. The reason I would eliminate the y is that the signs are opposite. But the question is, what can 3 and 2 both go into? And so we want our lead coefficient to actually be 6. So the first equation, we're going to multiply by 2. The second equation, to get a 6, we're going to multiply by 3. So please, as you're doing this, if you would show how you rewrote, and the most common mistake is people forget to take the 2 times the -19 over here and the +10. So rewrite your equations, add them up. Remember, your solution is an ordered pair. Good luck finishing these two. I know you're going to do great. We're going to have lots of practice tomorrow in class to go over these, to look at new ones, and practice and do quite a bit of this so that you're understanding it better. See you in class.